Welcome, dear students. In today's session on my classroom, we will be looking at a very interesting concept of divisions and distributions of permutations and combinations. So, divisions and distributions, where do we use this? Let's say I have 10 balls and I have to distribute it among 3 people. Or I have to collect total of 10 coins from 5 people. How can I do that? So all such type of questions fall under divisions and distributions. Now, there will be a lot of varieties of questions in divisions and distributions, and so that there is absolutely no confusion at all, these are the things which you have to keep in mind while reading the question on distributions and divisions. What are the things which you have to keep in mind? First and foremost, you have to see whether the objects which you are distributing are identical or distinct. Am I distributing 10 different fruits among 3 persons, or am I distributing 10 identical fruits among 3 persons? So first and foremost, you have to keep in mind whether the objects which you are distributing are identical or distinct. Second thing, whether they are groups or parcels, or the boxes are identical or dissimilar. That is, if you are giving 10 things to 3 persons, persons are all different. So they fall under parcel category or distinct boxes. Or if say I have 3 identical boxes and I am putting 10 things into it, so this falls under groups or identical boxes category. So you have to be very clear whether you are dividing among groups or parcels, dividing into distinct boxes or identical boxes, or whether the order among the groups matters or not. This is the second point which you have to keep in mind. And third thing which will be specified in the question is whether the sizes are given in is up to you. Like I am distributing 10 fruits among 3 persons A, B, C. Now it is my choice how much ever I want to give to A, how much ever I want to give to B, how much ever I want to give to C. This is unsized group. Or let's say I have to divide 10 things among A, B, C such that A gets 3 things, B gets 2 things, and C gets 5 things. These are sized groups. Sizes are already mentioned in the question. So you have to again keep in mind whether the groups are sized or unsized. So if these 3 things, if you it will be a very simple question. And now what to do in which case? So first and foremost, you have to see whether the things are distinct objects or identical objects, whether you are distributing identical objects or distinct objects. So more of identical objects I will deal with you in multinomial theorem, the next video. So this will cater to most of the identical things. Distinct things, let's focus carefully here. When you know you are distributing distinct things among persons or among boxes, you have to check whether they are sized or unsized, whether you can distribute as per your choice or whether the sizes are given in the question itself. Now, if the sizes are given in the question, then next question what you need to ask is whether the sizes are equal or unequal. So, equal will need a special treatment, unequal will be simpler. So we will see all of these cases one by one. So in each of these cases, you have groups or parcels. Group when the boxes are identical, order within the group matters, or boxes are distinct, or you are distributing among persons. That is when parcels come into picture. Now, other than this classification, there will also be one variety of question where distinct objects you are putting into different boxes, but order within the box also matters. Order within the boxes also matter. So let us look at all of this one by one. And this PPT will be shared to you in the link. You download it and keep this completely in your mind so that there will be absolutely no confusion while doing the problems. First category of the question, division of distinct things. So initially we will be dealing with distinct things. We are dividing distinct things and are of unequal sizes. Okay, sized but unequal. How will the question be? I am distributing 10 distinct things among 3 persons A, B, C such that A gets 3 things, B gets 2 things, C gets 1 thing. In case of dividing m plus n different things, how many different things I have? M plus n different things can be distributed into 2 different groups, m and n. M and n. So whenever unequal sizes, whether they are groups or parcels, they are both same. Okay, the difference comes only when they are of equal sizes. So whether you call it group here or parcel here, whether they are identical boxes or distinct boxes, absolutely there will be no difference whenever they are of things, and I have to divide them into 2 groups, one containing m things, another containing n things. So here distinct objects, sized groups, unequal sizes. M is not equal to n. M is not equal to n. In how many ways you can do this? It is m plus n factorial by m factorial into n factorial. You can happily remember this, and you getting this is very simple. Now, person A is getting m things, person B is getting n things. Out of total, how many? M plus n. So, from m plus n, you choose m things to be given to A. How many ways you can make the choice? M plus n, C n. M plus n, C n. Give those n things to A. Automatically, remaining m things will go to B, and m plus n, C n is nothing but m plus n factorial by m factorial into n factorial. So m plus n things, you have to give m things to A. You can do that in how many ways? M plus n, C, m. Okay, that's it. That will be your answer. Next result, the number of ways of distributing m plus n plus p things, m plus n plus p different things among 3 persons A, B, C such that A gets m things, B gets n things, C gets p things. In how many ways this can be done? M plus n plus p factorial divided by m factorial, n factorial, p factorial. Okay, this is same as out of m plus n plus p things, select m things to be given to m or A, m plus n plus p cm. Okay, give them to A. How many are remaining? N plus p things, of which you have to give n things to B. In how many ways? N plus p c n. Remaining will automatically go to C. So what will be the result here? M plus n plus p cm multiplied by n plus p cn multiplied by pcp. That will automatically come down to m plus n plus p factorial by m factorial into n factorial into p factorial. So this is how you distribute n distinct things among groups or parcels whenever things are of unequal sizes, parcel or group, or whether you are distributing into identical boxes or different boxes, both the results will be one and the same. Okay, so this is the first part of it. Now coming to equal sizes, let's say you have two and different things, and you have to divide into two different groups. You have to divide into two different groups. Order is not important. That means the boxes are identical. That means the boxes are identical. Order among the groups is not important. That means you are dividing into identical boxes. So in that case, what happens is the result would be 2n factorial by 2 factorial into n factorial into n factorial. So what is happening is I'm dividing in two identical boxes. I have total 2n things. From 2n, I am selecting n and putting in one box. The remaining I am putting in the other box. How many ways I can do that? 2nc n. 2nc n. Whether these n things are here or they are here doesn't matter. So this order doesn't matter. So I have to divide by 2 factorial. So result will come out to 2ncn divided by 2 factorial, or 2n factorial by 2 factorial into n factorial into n factorial. And if the order of the groups is important, that means the boxes are distinct, or you are dividing among persons Order of the groups when it is important, of course, the 2 factorial will not be there in the denominator. This will be classified into a parcel. So wherever the groups are different, we call them parcels. So whenever order among the groups is important, that whatever you have divided by 2 factorial will not be there. That's it. So this will be similar to the previous case where we are doing unequal, m plus n, m is same as n, you will get the result. So only when the boxes are identical, you have to be careful to divide the permutation among the boxes, that is by 2 factorial if you have 2 identical groups, 3 factorial if you have 3 identical boxes. In the same thing, let us look at another extended result. If I have mn different things, the number of ways of dividing into m different groups. Into how many different groups? M different groups. Order is not important. Here, boxes are all identical. Order is not important. In that case, what will I do? Mn factorial divided by n factorial whole power m, n factorial, each box will be having nn things. So, n factorial will come m times. And because order among the groups, I have to divide by m factorial. M factorial. Let's say same mn things I am distributing among m persons. In this case, which person is getting what will also matter. That means the boxes are not identical. They are distinct boxes. So order among the groups will also be important. Order among the groups will also be important. In that case, what will be the difference? This m factorial will not be there. This m factorial will not be there. So what will be the result? Mn factorial by n factorial whole power m, simply n factorial by n factorial power n. So let us see some examples on this, how to make use of this. First question, find the number of ways of dividing 100 cards into 2 groups of 60 and 40 cards respectively. 100 cards are to distribute into 2 groups of 60 cards and 40 cards respectively. So the sizes are not same. So whether the groups are identical or different, or boxes are identical or different, doesn't matter. What is it? 100 factorial by 60 factorial into 40 factorial. Or from 100, select 60 and give it to first one. 100 is 60. Or 100 factorial by 60 factorial into 40 factorial will be your answer. As simple as that. Look at next question. Find the number of ways of dividing 50 books into 2 groups of 25 each. 50 books into 2 groups, simply 2 groups. There is no order. Unless and until it is mentioned, order is not important. So, had it been among 2 persons, order would have been important. Had it been to 2 different stores, order would have been important. But here, nothing of that sort is there. Simply you are dividing into 2 groups. So order is not important here, and sizes are equal. So in this case, what you have to do? Divide by the 2 factorial additionally. So what will be your answer? 50 factorial by 25 factorial whole square into 2 factorial in the denominator. So 50 factorial by 2 factorial into 25 factorial whole square. That will be the result. That will be the result. So whenever the order among the groups is not important, you have to divide by this 2 factorial additionally. Next example, at an election, 3 wards of a town are canvassed by 3, 4, 5 men respectively. There are 3 wards in the election, and each ward is canvassed by how many? First one by 3, second one by 4, third one by 5 men respectively. So from 15 volunteers, how many volunteers you have in total? 15 volunteers. How many ways can they be allotted to different wards? So this is a little simple question where you have to be careful. It is not simply 15 factorial by 3, 4, 5 factorials. Here, the sum of 3, 4, 5 is what? So technically you have 4 groups. I have to allocate 3 persons for ward 1, 4 persons for ward 2, 5 persons for ward 3, and 3 persons are left out. 3 persons are left out. So technically there are 4 groups of people. One allocated for ward 1, second allocated for ward 2, third allocated for ward 3, and another set which is left out. So out of 15 people, 15 factorial, 3 people are allocated to ward 1, 3 factorial, 4 are allocated to ward 2, 4 factorial, 5 are allocated to ward 3, 5 factorial, 3 are left out, 3 factorial. So what will be the result? 15 factorial by 3 factorial into 4 factorial into 5 factorial into 3 factorial. So whenever the sum is not coming out to 15, the remaining difference you have to cater it as a separate division. Next question. In how many ways 12 different books can be separated into 3 equal groups? Into 3 equal groups. So when they are simply to be separated into 3 groups, order among the groups will not be important. Whether I could put the first set of groups here and second here or here doesn't make the difference. So their treatment should be like identical boxes. So what will come here? Each group will have 4 books in it. 12 factorial by 4 factorial, 4 factorial, 4 factorial, 4 factorial whole cube. And because the boxes are identical or we are simply dividing into groups, another 3 factorial will be there additionally. And second part of the question is, in how many ways they can be distributed among 3 persons equally? When you are distributing 12 books among 3 persons, now the boxes are different. So the denominator will not have any 3 factorial. Denominator will not have any 3 factorial. So denominator will have 3 factorial in case of equal groups and will not have 3 factorial when you are distributing among persons. That is the whole difference. That is what you need to keep in mind. 20 different things are to be distributed among 4 boys so that a particular boy gets 5 things, 8 things. A particular boy, let's say the boys' names are A, B, C, D. A is getting 8 things and the remaining boys are getting 4 things each. Remaining boys, how many more are there? 3 boys. They are getting 4 things each. So on the whole, there are 20 things. 8 things are going to first boy and remaining boys are getting how many? 4 things each. 4 plus 4 plus 4 is 12. So find the number of ways of doing so. So 20 things are to be distributed among A, B, C, D such that 20 factorial by 8 factorial, 4 factorial, 4 factorial, 4 factorial. So what will be your answer? 20 factorial by 8 factorial into 4 factorial whole cube. 20 factorial by 8 factorial into 4 factorial whole cube. Simply. Next question. Find the number of ways of distributing 40 different things into 5 identical boxes. 5 identical boxes such that 2 boxes have 5 things each and the remaining have 10 things each. So 40 different things are to be put into identical boxes, 5 identical boxes such that 2 boxes have 5 things each and the remaining 3 boxes have 10 things each. So part of them are equal sizes, another set of it is equal sizes. So order among these 2 will not matter, order among these 3 will not matter. So it is not that all 5 are of equal size. Of 5, 2 boxes are of equal size and another 3 boxes are of equal size. So order among these 2 boxes will not matter. Similarly, order among the other 3 boxes will not matter. So what will be the treatment here? 40 factorial is the total number divided by 2 boxes are containing 5 elements each. So 5 factorial whole square and order among the 2 will not be important. So have a 2 factorial here. Remaining 3 boxes are containing 10 things each. So 10 factorial whole cube and these are all 3 identical boxes now. So 3 factorial you have to use. So this is how you divide or distribute distinct things among identical or different boxes. Let us look at next category. Division of distribution of unsized groups. So where in the previous cases sizes were mentioned, like this boy was getting 5 things or one of them was getting, all of them were getting equal things. But here if size is not given, simply it is I have to distribute among A, B, C as per my choice. First chocolate I can give to any one of A, B, C, 3 ways. Second chocolate I can give to any one of A, B, C, 4 ways. So total 3 power 10 ways I can make the distribution. So similarly, if you have to distribute n distinct things into r distinct boxes or persons, you can do that in how many ways? R power n. R power n. Order within the box here will not be considered. So it doesn't matter to a child in which order the chocolate is given. It simply matters to him at the end of the day how many chocolates he got and what all chocolates he got. Okay. So how many ways that distribution can be done? R power n. How? Take the first thing, put it in any one of the R boxes. In how many ways you can do that? R ways. And second thing, again can be put into any one of the R boxes. Third, can be put into any one of the R boxes. So R, so on, how many power R's R? So n R's, R power n. Next part of the similar question would be, how many ways to distribute n distinct things into R distinct boxes if empty boxes are not allowed. If empty boxes are not allowed. So this falls under inclusion exclusion principle. First I divide all the n things among R boxes in R power n. From this I subtract the case where one of the boxes was empty. I will select the box RC1, remove that box and distribute among the remaining R minus 1 boxes. In how many ways? R minus 1 power n. But here you will be subtracting in excess. So by inclusion exclusion principle, you have to add the case where two boxes were empty, select the two boxes to be empty, RC2, distribute among the remaining R minus 2 boxes in R minus 2 power n ways. Again, you have to subtract three boxes being empty, so on, continue this. So inclusion exclusion principle here, none of the boxes should be empty. From the total R power n, subtract the case where one of the box was empty, choose the box, distribute among the remaining n R minus 1 boxes, but you will be subtracting in excess. So you have to add the case where two boxes were empty. Again subtract the case where three boxes were empty. Add the case where 4 boxes were empty and continue. So this is the formula when you have to divide n distinct things among R distinct boxes. Order within the box doesn't matter. That we will look at the last where when the order matters. Order doesn't matter, and empty boxes are not allowed. None of the boxes can be empty. I have to distribute 10 chocolates among 3 children, A, B, C, such that each child gets at least 1 chocolate. So what will that be? 3 power 10 minus, select the case where I am not giving a chocolate to one of the people, 3C1 into 2 power 10 plus 3C2 into 1 power 10. That is how you do this question. Next, division of identical things. This we will do it in more detail in multinomial theorem. Just I will tell you the basic principle, how it works. If you have identical things, I have 10 identical things, and I have to distribute them among R distinct boxes, or I have to give this 10 identical things among 3 persons. So those questions fall under this category. In how many ways I can do that? N plus R minus 1, C R minus 1. N identical things can be distributed among R persons. In how many ways? N plus R minus 1, C R minus 1, if empty boxes are allowed. That is, 10 identical chocolates I am distributing among 3 persons. It is for me to decide which boy gets how many. There is absolutely no condition. I may not give a particular boy anything. In that case, what will be the formula? 10 plus 3 minus 1, C 3 minus 1. N plus R minus 1, C R minus 1. Some questions may be such that empty boxes are not allowed. That is, each boy should get at least 1 chocolate. So in that case, it will be N minus 1, C R minus 1. N minus 1, C R minus 1. If N identical things are to distribute among R boys or R distinct boxes such that each boy gets at least 1 thing. What will that be? N minus 1, C R minus 1. This I'll discuss more in detail with many varieties of questions in multinomial theorem. That will be our next video. So where do we use this? N identical balls into R distinct boxes or among R persons. Let's say I go to a fruit market where there are n varieties of fruits. There are apples, mangoes, oranges, plenty of other varieties. There are R varieties of fruits. There are R varieties of fruits. Now, I have to pick n fruits in total. My mom asked me to bring 100 fruits from a fruit market where there are 5 varieties of fruits: apples, oranges, bananas, goa, papaya. Now, in total, it is my choice which I bring, how many. All the fruits of a particular variety are all identical. It is for my choice how many apples I bring, how many papaya I bring, how many oranges I bring, but the total has to be 100. But the total has to be 100. In such case, we use this particular formula. So n identical things are to be taken or given is one and the same. Okay, n identical boxes. So like shopping in a fruit market, or I have to get, let's say, 80 marks in an examination which has maths, physics, and chemistry paper. It is up to me to decide how many marks I want to get in physics, how many in maths, how many in chemistry. But at the end of the day, maths marks plus physics marks plus chemistry marks should be how much? 80. Or how many marks I can get, how many ways I can get 250 marks in JE. Okay, so effectively I have to load 50 marks out of 300, and 50 marks can be lost all in mathematics or some in maths, some in physics, some in maths, some in physics, some in chemistry. But the total of the marks I'm losing in maths, physics, and chemistry, that sum total should be 50 marks. So all such types of questions where sum total, you get an equation of the form x plus y plus z is equal to some number 100, 50, whatever, will fall into the category of this particular thing, n identical balls into r distinct boxes. Another category of question where we have is distribution of n distinct things into r distinct boxes. Boxes are also different, things are also different, but order within the box is considered. That was the last category which we have put in the slide. Order within the box is also important. So what we do is, first we decide which box is getting how many, in how many ways, n plus r minus 1, cr minus 1 ways, and then we permute all the things in these particular places. In how many ways? N factorial. So what will it be? If you have n distinct things, if you have to distribute them among r distinct boxes or r persons, empty boxes allowed, and order within the box is important, order within the box is important, then that can be done in n factorial into n plus r minus 1 c r minus 1. Then this previous formula n plus r minus 1 will now change to n minus 1 c r minus 1. You will be permuting in n factorial. So if this boxes where order within the box is also important. Order within the box is also important. In how many ways you can do that? N factorial into n minus 1 c r minus 1. If empty boxes are not allowed, if empty boxes are allowed, then it will be n factorial into n plus r minus 1 c r minus 1. What kind of questions can be asked on this? Let us see it by a proper example. You will understand it well. Let's say there are some counters before a cinema hall. Now, 100 people should be standing before 3 counters of a cinema hall. 3 counters are different, 3 different boxes. 100 people are also different. 100 people have to be distributed among 3 counters, and order in which they stand before each counter, that is also important. Yes or no? The order in which you are in a queue before each of these counters will also be important. So such question falls under the previous category. So 100 people, if they have to stand before 3 counters in a queue, in 3 queues, then how many ways you can do that? 100 factorial multiplied by 100 plus 3 minus 1 c3 minus 1. If empty queues are allowed, a counter may not have any person. If empty queue is not allowed, every counter should have at least one person. Then how many? 100 factorial into 100 minus 1 c3 minus 1. As simple as that. Or you have a pile of books. Now you want to put them in. Okay, let's say I have 50 books, all different. I have to put them on my table on 3 piles, 3 vertical piles, 3 vertical columns. In how many ways you can do that? You can choose as many books on each pile. You can choose as many books on each pile. Absolutely no restriction on that. Once you're putting, now which books comes on the top, which books comes on the bottom will become important. Yes or no? The bottom one is bearing the weight of all of them. And the top one is relaxed. Toppers are always relaxed. So 3 piles, I am putting 50 books. If in a pile, I need not put a book, all of them in 2 books. If it is allowed, then it will be 50 factorial into 50 plus 3 minus 1, say 3 minus 1. If in each of these columns, I have to put at least one book, empty columns are not allowed, then it will be 50 factorial into 50 minus 1, C 3 minus 1, as simple as that. Or if I have to put rings on my finger, I have 10 rings, I have to put them on these 4 fingers. Ring here and blue color ring here, if it is different from having a red color ring and blue color ring here, then order if it is important, I have how many? 10 rings, I have to put them on 4 fingers. Order on each finger is also important. I may not put any ring on this finger, then how many cases? 10 factorial into 10 plus 4 minus 1, C 4 minus 1. Now, if I have to put at least one ring on each of these fingers, then how many? 10 factorial into 10 minus 1, C 4 minus 1. I hope you are clear with this entire classification. You will find this PPT in the link below you. Go through this once again, and this will ensure you perfection on division sign. Subscribe to the channel.